All right, guys, before we get started, are there any questions over any of the assignments so far? Any questions over any of the homework assignments? All right. If there's no questions over the assignment, we're going to continue working on 7.5. And what we're looking at today is 7.52. So we're continuing with solving these rational equations, Now, the first thing we need to do when looking at the rational equations is make sure all the denominators are factored as far as they possibly can go. So our three denominators that we have here are x plus 1, 2x, and 2x. X plus 1 is simplified as it gets. There's no greatest common factor. The degree is 1. 2x and our 2x are simplified because it's a single term. So since they are simplified, we can start off by looking at our restrictions. Our restrictions are going to be helpful because if one of the restrictions does show up, we can throw that solution out. And there's two places where we can have a denominator of 0. One of them is x plus 1 and the other is 2x. So with the x plus 1, we would subtract 1 from both sides, telling us that if x is equal to negative 1, we would have a denominator of 0. That doesn't work. Our 2x, well, we can divide both sides by 2, really telling us that x cannot be 0. So if we get 0 or negative 1 as a solution, we're going to throw that solution out. Now we need to figure out what our least common denominator is, what we're going to multiply through this entire equation by to get the denominators to simplify. 2x and x plus 1. So if we start with 2x, in the middle our 2x and 2x will cancel. In the far right, the 2x and 2x will cancel. And the only other denominator we have is the x plus 1. And the far left, the x plus 1 and x plus 1 will cancel. So let's see what that leaves us with. It leaves us with 3x times 2x. Well, our 3 times 2 is 6. X times x is x squared. Minus 5 times x plus 1 is equal to 3 times x plus 1. Now, there's a good chance we're going to have a quadratic equation. We have that 6x squared, so we're probably going to have to get this equal to 0. 6x squared, we'll say as it is. We're going to have to distribute the negative 5. Negative 5 times x is going to be negative 5x. Negative 5 times 1 is going to give us negative 5. On the other side, we're going to distribute the 3. 3 times x is 3x. And 3 times 1 is 3. Now, we still have our 6x squared term. All right, guys, focus up here. So we need to get this thing equal to 0. So the first thing we can do is subtract 3x from both sides. So we have our 6x squared, negative 5x minus 3x would give us negative 8x. Minus 5 is equal to 3. Lastly, we can subtract 3 from both sides, telling us that 6x squared minus 8x minus 8 is equal to 0. Questions on how we got to this point here? Now, looking between these three terms, is there a greatest common factor? 2. And if we factor the 2 out of all three terms, it's going to reduce our 6x squared to 3x squared. It's going to reduce our 8x to 4x and reduce our 8 to 4. So we'll have our two sets of parentheses with 3 spaces. Since the third term is negative, our signs are going to be opposite. Only factors of our 3x squared, well, the x squared is x and x. And our 3 is going to be 1 and 3. So where do we want to put the 3? With the first x or the second x? All right, I'm going to put it with the first one. Now we have a few more factors for 4. We have 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. And if we check this here, 3x times negative 2 would be negative 6x. 2 times x would be plus 2x, giving us negative 4x, which is the middle term that we wanted. Since we do have the correct middle term and we have 2 or more things multiplied together to equal 0, one of these is going to have to be 0. Either 3x plus 2 is 0 or x minus 2 is 0. We can start off with our 3x plus 2. So at this point here, we just need to solve. If we subtract 2 first, it'll tell us that 3x is equal to negative 2. Divide both sides by 3, telling us x is negative 2/3. On our other equation, x minus 2, we can add 2 to both sides, telling us that x is equal to 2. Our 2 and negative 2/3 are either one of those a restriction? No. So both of those are our solutions. Questions on this here? All right. Let's look at the next one. So we're given this equation here. We've got 4x plus 1 over x plus 1 is equal to 12 over x squared minus 1 plus 3. So as we look at this here, are all the denominators factors as far as they can go. Well, no. The x plus 1 is simplified as it gets. Yes, the x squared minus 1 is a difference of perfect squares. We can actually factor it. 2x plus 1 and x minus 1. It would have been very tempting to want to multiply this through by x squared minus 1 and x plus 1. But doing that would give us an extra factor of x plus 1 that we don't need. Restrictions. So after we factor the x squared minus 1, it's going to help us, one, be able to figure out what we need to multiply everything by, as well as figure out what our restrictions are. Now with our x plus 1, we can subtract 1 from both sides, telling us that if x is equal to negative 1, it would cause a division of 0. That's not going to work. The x minus 1, we can add 1 to both sides. And if x is positive 1, we'd have a division of 0. That doesn't work. So our restrictions for this here are positive or negative 1. Questions on this so far? Now we need to figure out what we need to multiply through by. I would agree with the x plus 1 and the x minus 1. Now the 3 doesn't have a denominator, so we don't have to multiply through with it. Because if we do the x plus 1, on the far left, the x plus 1 and x plus 1 will cancel. In the middle, the x plus 1 and x plus 1 will cancel. And since our 3's denominator is 1, we don't have to worry about it. In the middle, the x minus 1 and x minus 1 will cancel. And what that leaves us with is 4x plus 1 times x minus 1 is equal to 12, because what we multiplied it by in the denominator simplified out completely, plus 3 times x plus 1 times x minus 1. Questions on this so far? Now at this point here, we're going to have to do some simplifying. So here we can distribute the 4x. 4x times x is going to be 4x squared. 4x times negative 1 is going to be negative 4x. 1 times x is going to be plus x. And 1 times negative 1 is negative 1. Now we're also going to have to multiply our x plus 1 and x minus 1. Well, x times x is x squared. X times negative 1 is negative x. 1 times x is going to be plus x. And 1 times negative 1 is, well, negative 1. On the left-hand side, we can combine like terms. Our negative 4x plus x would be negative 3x. On the right-hand side, our negative x plus x is going to be 0. Simplifying the x plus 1 times x minus 1 to x squared minus 1. Which really shouldn't be that big of a surprise, because we got the x plus 1 and x minus 1's factors from what? X squared minus 1. So it should be expected that x plus 1 times x minus 1 should simplify back together to give us x squared minus 1. We'll need to distribute the 3, telling us 4x squared minus 3x minus 1 is equal to 12 plus 3x squared minus 3. And lastly, we do have some like terms. Our 12 minus 3 would give us 9. Questions on this here before we get this equal to 0? Now, out of all the terms, we can move first. And yes, that should be a 2, not a 3. I would move the square terms over first. So I'd subtract the 3x squared. Because on the right-hand side, the 3x squared and 3x squared will simplify, leaving us with 9. On the left, 4x squared minus 3x squared is x squared. Minus 3x minus 1. Because the nice thing about combining our x squared terms, our variable with the biggest exponent first, is that if for some reason it's actually been 4x squared instead of 3x squared, our x squareds would have canceled out, then we can just go about getting x by itself. So if they cancel out, then we can do other things with it. But here they didn't, so we still have to go about getting this equal to 0. So the next thing we can do is subtract 9. Minus 3x minus 10 is equal to 0. Since the x squared, the number in front of it's 1, there's a good chance it'll graph and graph nicely. But we could probably at this point factor it just as fast. Since the 10's negative, our signs are opposite. Factors of x squared are x and x. Now the factors of 10 are 1 and 10, 2 and 5. 2 and 5. The 2 is first, 5 is second. And if we do check this here off to the side, X times negative 5 would be negative 5x. Plus 2x equals negative 3x, which is the middle term that we wanted. Which means we do have two things multiplied together to equal 0, telling us that either x plus 2 is equal to 0 or x minus 5. So we solve our first one by subtracting 2, which indeed is telling us x is equal to negative 2. Next one, we would add 5 to both sides, telling us x is equal to 5. Negative 2 or 5. Questions on any of this here? Now again, with any of these here, negative 2 and 5, neither one of those was one of our restrictions. But if we wanted to, we could check this to make sure that they worked. And all we'd have to do to check it is say 4 times 5 plus 1 over 5 plus 1. And see if that equals 12 over 5 squared minus 1 plus 3. We just plug that value of x back in. At this point here, we could grab the calculator. Fraction 4 times 5 plus 1 over 5 plus 1. 7/2. On the other side, we have 12 over 5 squared minus 1 plus 3, which is 7/2. So this here is telling us that 7/2 is equal to 7/2. That's a true statement, so that works. The other is negative 2. So we can say 4 times negative 2 plus 1 over negative 2 plus 1 is equal to 12 over negative 2 squared minus 1 plus 3. And again, we can pull the calculator up. Fraction 4 times negative 2 plus 1 over negative 2 plus 1. Tells us we have 7. On the other side, we'll have 12 over negative 2 squared minus 1 plus 3 is 7. Again, we get another true statement. So both 5 and negative 2 work. Questions on this here so far? Questions on anything we've done so far? All right. Let's look at this here. Are the three denominators factored or simplified as far as they can possibly go? No, our middle one, x squared minus 9, is indeed a difference of perfect squares, which will indeed factor to x plus 3 and x minus 3. Yes. Which does indeed end up being the least common denominator, x plus 3 times x minus 3. Now our restrictions, well, minus 3, telling us that if x is equal to negative 3, we'd have a division of 0, so that doesn't work. For x minus 3, if the x value is positive 3, it would have a division of 0, and that one won't work. Questions on this so far? Now we start multiplying through. We'll start with x minus 3. On the first one here, x minus 3 and x minus 3 cancel. In the middle, the x minus 3 and x minus 3 will cancel. And the last one, the x minus 3 won't, because the denominator is x plus 3, which means we'll also have to multiply through by an x plus 3. Now in the middle, the x plus 3 and x plus 3 will cancel. And in the last one, the x plus 3 and x plus 3 will cancel, leaving us with 6 times x plus 3 is equal to 8x squared. But since the middle term, denominator canceled out with both, we're just left with 8x squared minus 4x times x minus 3. Now on the right-hand side, we'll have to distribute the 6. 6 times x is 6x. And 6 times 3 is 18. Now we'll still have the 8x squared, because we'll need to distribute the negative 4x. Negative 4x times x is going to be negative 4x squared. Negative 4x times 3 is going to be plus 12x. Now when we combine like terms, our negative 8x squared minus 4x squared will give us positive 4x squared. At this point here, we do need to get it equal to 0, so we can subtract 6x from both sides, telling us that 18 is equal to 4x squared plus 6x. And lastly, we can subtract 18 from both sides, telling us 0 is equal to 4x squared plus 6x minus 18. Questions on this here? So we can factor this. 4x, 6x, and 18 has the greatest common factor of 2. And if we factor the 2 out, we're left with 2x squared plus 3x minus 9. Since the 9 is negative, our signs are opposite. Factors of x squared are x and x, 2 and 1. Factors of 9 are 1 and 9 or 3 and 3. Which one do we want to try first? Oh, we have the wrong one. 3 and 3. And if we check this here, 2x times negative 3 would be negative 6x. 3 times x is plus 3x, giving us negative 3x. Not quite the term we want, but almost. Since it's the correct number but wrong sign, we need to switch the signs. Because that'll now give us positive 6x minus 3x, giving us the positive 3x that we wanted. Since we do have the correct factorization, we do have 2 or more things multiplied together to equal 0, so one of them must be 0. Now with the 2x minus 3, the first thing we can do is add 3 to both sides, telling us that 2x is equal to 3. At this point here, we can divide both sides by 2. Minus x is 3 halves. Our x plus 3, the first thing we can do is subtract 3. Now this is the first time we've had one of the restrictions come up, but since negative 3 is a restriction, we have to remove it from one of the solutions, because x cannot be 3 or negative 3. So in this case, the only solution that we actually have is positive 3 halves. Questions on this here? All right. Last one we're going to look at today, we'll save the rest of the last two for tomorrow. But if we look at this here, the denominators are not all factored. Out of all of them, one of them is. And that's the x plus 3. Now out of the three of these, x squared minus 9 is going to be the nice one to factor. Because x squared minus 9 is indeed a difference of perfect squares. So it's going to factor to be x plus 3 and x minus 3. So we do have those there. Now we do need to factor the middle term. X squared minus 6x plus 9. So we'll have two sets of parentheses with three spaces. Since the third term is positive, the signs are the same, match the sign of the middle term. Factors of x squared are x and x. And the factors of 9 that we end up wanting are indeed 3 and 3. Which will be nice, especially for our restrictions. Because our restrictions are going to be just like the last problem. We have x plus 3 and x minus 3. So with our x plus 3, we can subtract 3 from both sides, telling us x cannot be negative 3. For x minus 3, we would add 3 to both sides, telling us x cannot be 3. So if we get 3 or negative 3, like the last one, we would throw that one out. Questions on this so far? Questions on anything we've done so far? Now at this point here, we need to reduce the denominators. So we can multiply 3 by x plus 3 and x minus 3. And in the far left, the x plus 3 and x plus 3 will cancel. X minus 3 and x minus 3 will cancel. On the far right, the x plus 3 and x plus 3 will cancel. And in the middle, the x minus 3 and x minus 3 will cancel. But since there's only one of them, it's only going to cancel with one of them. Questions on this so far? Are all the denominators simplified? No, because the middle one has how many x minus 3s? It has it twice. So that means for both of them to cancel, you have to multiply everything by the x minus 3 twice. Since it showed up twice in one of the denominators, we need it twice. So let's see what that leaves us with. We have our 4x times x minus 3 is equal to x minus 1 times x plus 3 plus 2 times x minus 3 times x minus 3. Let's do some simplifying here. We can distribute the 4x. 4x times x is going to be 4x squared. 4x times negative 3 is going to be negative 12x. Here we can distribute x squared plus 3x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3. Plus 2 times, here we can distribute the x. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And lastly, negative 3 times negative 3 would give us positive 9. Now at this point here, we can combine like terms. Now the 4x squared minus 12x, there are no like terms there. Our 3x and negative x are going to combine to give us positive 2x. And our negative 3x minus 3x will give us negative 12x, or negative 6x, sorry. Last thing before we can finish combining like terms is we do need to distribute that too. 2 times x squared is going to be 2x squared. 2 times negative 6 is going to be negative 12x. And 2 times 9 is 18. And our last combining of like terms before we get this equal to 0, x squared plus 2x squared is 3x squared. 2x minus 12x would be negative 10x plus 18. What can we do next? We can subtract 4x squared from both sides. When we subtract 4x squared from both sides, we get that negative 12x is equal to negative x squared minus 10x plus 18. What can we do next? Add 12x to both sides. Because our negative 12x plus 12x is going to be 0 is equal to negative x squared plus 2x plus 18. Questions on any of this here so far? Nope. Negative 3 plus 18. I knew something seemed off. Yep. Forgot to combine our constant terms. That negative 3 plus 18 will give us 15. If it was 18, it would still be solvable, but it wouldn't be rational. There's a good chance they would be irrational solutions. We can, yes. Now, this one here, I'm going to show you it by also graphing, because we could graph this also and see if it gives us nice solutions. Because if it does, that's going to make things nicer. Negative x squared plus 2x plus 15 graph. So it does cross the x-axis at 2 places. One of them is 5, negative 3. So 5 and negative 3. However, out of these two solutions, negative 3 is one of our restrictions. So the only solution that actually works is 5. Now, if we wanted to factor this, the first thing I would do is factor the negative out. Which will tell us that we have negative times our x squared minus 2x minus 15. 2 sets of parentheses with 3 spaces. Five and 3 for our factors of 15. And it'll tell us that x plus 3 is equal to 0, x minus 5 is 0. Here we would subtract 3 from both sides, telling us that x is equal to -3. Here we would add 5 to both sides, telling us x is equal to 5, as we found already. But x equals -3 is one of our restrictions. So we throw it out, just telling us that x is equal to 5. But we'll stop there for today.